All right, so if we have this object moving back and forth, we obviously are not just worried about it. Remember way back when, if we look back a long time into our distance, the first thing we talk about is position, velocity, time, acceleration. The basics of physics. We're defining our world. Then after a while, we get to things like forces, which we talked about, F equals negative kx. And then we get to energy. And we can see that this energy, if I pull it here, it wants to move. And an object that wants to move has potential energy. And potential energy is the potential for kinetic energy, which we can see. So if we look at the extreme, U equals 1/2 kx squared, which, do I need to derive that from the force equation, or we're all able to do that with calculus?
Yeah.
Okay, I don't even want to mess with that. Well, where would the maximum potential energy be?
At the greatest distance from equilibrium.
Would you agree with that?
I would.
And so where would our maximum kinetic energy be?
At x
1/2
equals 0.
mv max squared. And by conservation of energy, if there are no outside forces and no work being done, then we can set the energy of one equal to the energy of the other, equal to the energy at any given point along its path, and we get the energy for a spring is this is at maximum displacement, or the turnaround points, right?
Yes.
That's at the very edges. Right here is where?
Right
X
in the
equals
middle.
0 at the equilibrium position.
And you're the one
And
who's
this right here would be
anywhere.
anywhere.
Wow. My gosh, it's a universal equation.
And by the way, we took these two equations and we just decided to follow the white rabbit a little bit. Notice how the 1/2s cancel?
Yes.
And I get Ka squared equals mv max squared. Well, you know, velocity is distance divided by time. And which would equal my distance around the entire circle would be 2 pi a, the circumference, divided by the period squared, which would give me k over m, the a squareds cancel, equal 2 pi over t squared. Take the square root, and guess where we end up again? T equals 2 pi square root of m over k.
But there are multiple routes of finding this equation.